Anmol, the first question you put to me concerned turning this equation, arg of z minus 2 plus 3i equals minus 2 pi over 3, into its Cartesian form. Well, we should recognize, first of all, that there's a translation implicit in this little expression here, and if we rewrite this as arg of z minus bracket 2 minus 3i equals minus 2 pi over 3, then we've got the very point to which the origin has been translated right here. So on this little diagram, it's 2 steps to the right and 3 steps down. So that's our new origin. And if we draw a line to the right, that will be our new initial line. That should be parallel to the x-axis. An argument of minus 2 pi over 3 is, I think we can recognize that as minus 120, so that would take us to there, wouldn't it? So there's the half line which begins at that point and goes in that direction. There we go. Now we don't really want this bit here, but we'll deal with that later. Now we have this formula y minus y1 equals m of x minus x1 when we have a point through which a line passes and we know the gradient. Well, this is the point 2 minus 3, so we can immediately fill in y minus negative 3 equals something x minus 2. We'll keep that as m for the moment, and that gives us y plus 3 equals something times x minus 2. Now this something is nothing other than the tangent of minus 2 pi over 3. And that will work in every case, giving you a negative gradient when that's appropriate and a positive gradient when that's appropriate. So now we've got a Cartesian expression, a Cartesian equation, and you might be asked to manipulate it and put it in the form y equals mx plus c, or ax plus by plus c equals 0, or whatever. But how do we deal with this little issue that we don't want this bit of that straight line, which is implied in this Cartesian equation? Well, it's simple enough. We just have to restrict the domain to x is less than or equal to 2, and that will mean that it's only the half line going in this direction which is now being expressed by this whole equation and inequality.